Any problem regarding LabVIEW?
Yeah, I tried some random example. Actually, in the what is the digital waveform graph. I
Okay.
think in the like example for 61, I tried to get the object name digital waveform, but in my version maybe it's not possible. I'm not sure what something error is. I
Uh,
cannot find in the digital waveform one.
Digital waveform graph mainly.
Yes, sir. Yes, sir. I
Okay.
cannot find this one.
1 minute. I just check. Your version is LabVIEW 2020 version.
20. Yes.
Okay. You just go through the course, that Udemy course.
Unique course.
You
Yes, sir.
on
Yeah,
which
yeah, yeah.
in
You are sending one. So unique course.
okay,
Digital waveform. It's number 61 course contact.
okay, number 61. I just check. First, I just check in my version, in LabVIEW 2020 version, it is available or not. In the graph, you just looking for this digital waveform graph.
Yes.
1 minute, I just share my screen to you. My screen is visible to you.
Yes, and now sharing.
Okay. So
Yes, it's visible now.
over here in the graphs, this is the digital waveform graph.
But in the example, if you are clicking on the black diagram, you can select, we go for the waveform, and then the digital waveform option is there.
Uh, I just go to the
Black
waveform.
diagram.
Okay, okay. In the block diagram over here,
Waveform in
over
the
here.
digital waveform is there.
Okay. This one is not in your case.
Yes, sir.
You just
Okay.
need to means you just go to VIPM, VI package manager. Okay.
Yes, okay, manager. Okay.
Just go over here and just select like I just show you. 1 minute. VIPM, not VIPM and NIPM, because it is
Yeah.
related to NIPM, NI package manager. In this NI package manager, just type waveform graph.
Okay.
1 minute, it will take some time. uh, any other issue?
I tried in the one more example. I cannot understand the train uh, berth calculate berth seat allotment.
Please repeat.
The train berth seat
Okay, okay,
allotment.
okay, okay. Train berth seat allocation. Basically, it
Yes.
is related to mathematical equations. You can create
Oh.
any example. It is just an
Okay.
example, like in our previous lecture, we just go with the global random dice number. It is
Random
just
dice.
like that. We just select the seat number, and if it is available or not, you just go to the code, like I just check in my videos. I just show you the or explain you the block diagram window of the train and berth.
Okay.
Any issue with any code, you just share me on WhatsApp before the lecture.
Okay,
Okay,
sir.
any issue.
Okay. Okay.
VIPM is opening, NIPM is not. It is taking time, so we just continue with another examples till now. Any other issue?
Yes.
Train and
No,
birth
sir. No.
example is there. Another one is waveform graph, digital waveform. Other than this,
Remaining, I select on the random examples.
you right now
So
you
for
are right now my question is this: right now you are just checking videos, or you just tried on your own?
yeah, I'm also trying, sir.
Okay, you just go
Yeah,
through
I'm
all the
trying that.
examples. You just
If you
if like I
yeah,
also shared you the examples, you just develop these examples on your own using your
oh, okay,
2020 version. Okay,
okay,
so it is opening, taking more time, so I just go to the lecture. After this, I just show you how to install that waveform graph. So first case
okay,
is today, like how we go for local variable and global variable. In the previous lecture,
okay, sir.
we just check out with local variable. Like over here, I just have a numeric control. If you just want to create a local variable is just if you want to just put this value, or you want to just this value to another, you just want to show this value to different indicators without wiring. In that case, you just go with local variable. Like I have a code over here, or I have a sub vi. If you want to just go inside a vi, like in this case I have a this vi, and in this vi I want to just send one value from over here to this one a particular indicator. Like in this case I am just creating, like I just show this value to this indicator, or I just want to send this particular value of numeric, this one I want to just also send to this. You just connect it. One issue is with this: if you want to just remove wiring, in that case you just go to the numeric, create local variable.
Local variable.
Okay, so every value that is inside this, it goes to this also. Like I just make it read type. The option is different. Like in this case we just make it read type. When we read type,
Right, right.
make it read type, it will read from this value and give this read
Yes, sir.
value to particular indicator. Like over here
Okay, sir.
I just connect it. Another same way, you just use this value many times. In this case,
Multiple places.
yes, you just need not to wire from here only. Like I have a complicated vi, and I want to just connect the indicator from this end to this end. In that case, wiring is very heavy, so you just need to create local variable in this case. Okay, so
Okay.
in the MATLAB it is nearly equal to go to function. Go to,
Go to function.
yes, in the MATLAB we have a go to function. It is similar to that local variable. So right now I just, when I put some value inside it, let's say I just put 5 inside it. So both the indicators will show 5 value, as you see. Okay, there is no connection of this meter with this wire, but it is reading value from over here. Okay, so this is the case of
Okay.
local variable. It is in a single vi. If you want to just it is a vi, like I have an example. In my house, I am living, I just send my voice to my wife, send my voice to my child. But in the another house, let's say my neighbor house, I just want to call someone. So in that case, if you want to go with another house, then in that case you just use global variable. Okay, so you just send your voice, you just read the signals from that vi also using global variable. But in the case of local variable, you are working in a particular VI only or in a particular project only. Okay.
Okay.
So this is the case of local variable, but in the case of global variable, you just go to data communication. You just like in the previous example, I just create local variable by selecting over here create local variable. Okay, there is another way you can drag local variable from data communication port. Over here there is a data communication port and you can find out local variable and global variable both over here. These are blank variables, like in the case of arrays also. Like in the array we have blank array, we just make it floating type, we just make it integer type. Likewise we just create local variable and global variable. So over here you just drag local variable, this is a blank variable. So if you want to just put anything inside this, you just connect this local variable. So in this case over here you just want to select it like this. Okay, so right now it is a numeric floating type local variable, and in the case of global variable I just drag it. I just take an example of global variable over here. In this case just open it, double click on it, global variable. This is the VI of global variable. Okay, so in this case I just put two indicators over here, not indicator, control over here. So let's say this is my value 1, this is my value 2, and these values come from different VI and these goes to another VI. Okay, so over here these are my two variables. Now I just save it. I make it name global, save it, close it. Now when you just click on it, there are two values. These two values are related to that control created by me inside the global variable. So this is my 1, this is my second. You can copy it also. So over here I just put a numeric control, that is 1, another control that is named 2. Okay, so this is my numeric control over here, and I just put values inside these VI. So over here this is my 1, this is my 2. It will take values from this VI, that is my untitled united 1, untitled 1. Okay, so it will take values from over here. I just go with another VI, this is another house, or you can say in this house I just drag this global variable, and in this, using this, I just make it to read type. It will read the values from united 1, untitled 1 VI. I just make a operation over it. Let's say I want to multiply both the values and just create an indicator over here. It will show me the value. This VI untitled 2 and untitled 1, these two VIs are now connected through this global variable. Okay, there is no relation between, hello,
Yeah, yes, sir.
so right now I am just sending values, I am just changing values in the VI that is untitled 1, and it will change the value in the untitled 2 also. Let's check. So when I just run it continuously, right now it is showing 0 only. When I increase, it is not updating, because right now the values, right now it is not running. Okay, so when I just continuously run it, in this case you can check real time values that are transferred from untitled 1 to untitled 2 over here. So this is the use of global variable. When you just want to send some values from one program to another program that is not connected, so you just use global variable.
Okay.
In this case, but inside a VI, like in untitled one, if you want to just transfer some values from one place to another place, you just go with local variable. This is the main difference between local variable and global variable. Okay,
Global variable. Okay.
it is clear to you. You can use any way, like for example, you just create a program using your deck card. You just acquire the signal of pressure and flow, for example, in a program. In the another program, you just acquire voltage and current, and in the another program you just want to combine all these four. You just go with global variable in that case. Okay,
Okay.
so this is the case of global variable. And over here, this is my NIVIPM. So over here you just browse your products, search for digital waveform,
Digital wave.
and in this case you just find out digital waveform package. It is taking some time. There are different packages related to waveform, related to biomedical systems, related to robotics. It is loading.
Okay.
Some issue is there. 1 minute. Right now you have NIPM in your system.
Yes, sir.
You just check for waveform. Over here you just find out the package related to digital waveform. I just installed in my system, that's why it is available in my control palette.
Okay. It's searching now.
Right now it is loading. It is taking more time. Over here you just go with waveform.
Good waveform.
Over here different packages are available, like you want to go with programming environment, you want to go with application software, you have different suites related to your NI package over here. I just already installed. When you just first time install your LabVIEW, maybe you are not installing the complete system, that's why it is not available in your system. Okay, you just go with do you have any requirement of that digital waveform in your programming?
No, sir. Maybe the SCL, SDA clock signal data, maybe I can use for the waveform capturing.
Okay, okay. It is still loading. Right now, when you just go to the installed folder, how many packages you have in your system? Right now, as you see in my system, there are 216 total number of software
My
installed?
one is 273.
273.
Yes, sir.
You have more than me.
Maybe I install on all items.
Maybe not all items, but in
Hmm.
your system, as you told me that the waveform, digital waveform is not available.
Not aware.
Yes, it is available in
Uh,
2020 version. I because in 2015 version also it is available. You just go to, I just search it for 2020 version. I just update you after this lecture that
okay,
how to install this
okay,
system. I just share you a PPT also. Okay.
okay,
Okay. So right now this is the case of global variable and local variable. How to work with these two. Now I just have a example. You just explain me what is the operation, mathematical operation performed by this example. You just explain me. Okay. So over here I have example of waveform graph. When I hit on run button, it will create this type of figure to me. And over here, this is my formula. So will you please explain me what is this formula? What is the equation?
for loop x of 0.1 it is 0.10, 0.8.
It is visible to you properly?
Yes, visible. Yes.
Okay. You just explain me what is the formula inside or what operation this VI will perform.
Yes, 0.1 by divider. It's a second one is divider or addition?
Over
Sec
here, it is a addition.
addition.
Yes,
Okay.
addition.
This is a sine waveform.
Basically, if you just want to check which type of operation it is performing right now, as you see over here, my loop count is 50. It will generate, means it will run 50 times. My loop will run
Hmm.
50 times and iteration will go from 0 to 49.
Hmm.
Iteration in the case of for loop 0 to
0 to
49 because n minus 1.
49.
Okay. So now
50 mean.
Now, over here, as you see, this blue wire is directly connected to the for loop. Okay. This
For
iteration
loop.
is
Yes.
directly connected to the edge of for loop. Over here,
For
all
loop.
the values stored like 0, 1, 2, 3, 4, 5, 6 up to 49, all the values are stored. As you see in the case of front panel over here, we got these values 0, 1, 2, 3, 4, all the values over here. Okay. So these are my
Okay.
one column, another control E.
The
This
sine x. Yeah.
another is my sign operation, and the operation it is not sign
Sine
operation.
operation.
It is a basically as you see over here.
Sine cos.
I just let it x. Just let it x. Over here it is 3x.
X.
Over here
3x.
it is giving me 3x plus
3x and
0.1.
plus 0.1.
So over here I just type it 3x plus 0.1, then I just make it sign. Whole function goes to the sign. It will create sign
Sine x.
over here, sign of 3x plus 0.1. Okay, till now. Any issue?
No, sir. So correct.
Over here, right now it is 3x plus 0.1 of sin x. Okay, sin x of this value. So now further, I just multiply this value with 0.8, 0.8 into sine of 3x till now over here, till this value. Now I just multiply this value, the whole value, with -1. So I just put -1 before it. So minus 0.8 into 3 of x till now. And now this value, the whole value, is subtracted from 1. So this is my function. So over here, when I is 0, put x is 0 and the whole function is calculated and the value related to iteration 0 stored over here, and the value related to 0 is, we just go to the vi over here, as you see, -1.07987. okay, and it is just, and in the graph, as you see over here in the block diagram window, I just connect the waveform graph to the only this operation value, not the complete value, only this value. Okay, so the waveform graph only showing the value that is connected to this function value. Okay, if you just,
Sir, I have one question.
Sorry,
Uh, I have one doubt, sir.
uh,
For
just explain.
our LabVIEW is program is working from left to right only.
Yes,
correct? But in the -0 point is coming front, but actually it's coming backside of the sine of 3x. After that, it is the -0.8. Correct?
one minute. In the lab view, we just go from left to right. The program is
Yes,
executed from left to right.
left.
If
Yes.
you just make this type of function, I just copy it. 1 minute. I just copy it. So over here, as you see, this is my function. Okay, and it will
Yes.
take values from over here. I just make a control over here. Control V.
Yes.
It will take values from this x, and this x is my variable. It is 0, 1,
Correct.
2, 3, 4, 5 up to 49 in my case.
Up to 49.
Okay, so right now your question is that key, it is creating sine of x. It is,
Yes.
so sine operation, that this function over here, I just got the sine of this function only.
Yes, correct.
Okay,
Yeah.
sine of 3x plus 0.1 over here.
Okay, sir.
Now the whole value, because it is a some floating value, when you just perform any function, any value like sine of 0.43, maybe over here 0.43, we can check also, like over here I just create an indicator. Over here, this is my indicator, and over here also I just create an indicator. It will give me sine of x. Okay, so I just check, when over here it is 0, when I run it, as you got the value using this formula, that is my 3x plus 0.1, it will give me 0.1. It is okay.
Correct.
Now sine of 0.1 is this value, because it is in radian, not in degree.
Radian.
Okay,
Okay.
so it is sine of x. Now this value, that is 0.9 something, is multiplied by 0.8. Then it is available over here. Then I multiply it by -1.
-1.
Then it is this value, the coming value is subtracted, this value minus this value. That's why I got over here, when I just create indicator, I just also put indicator over here, so that we just check at different steps. So now I just go to the vi also. As you see, 0.1, it is sine of x. This is my last value, I just put it at the last. So over here, this is my sine of x, and this is my before 0.8. When you multiply this sine of x with 0.8, I got this value. When you just multiply this value with -1, only minus is present, the same value is there. It is visible to you,
Yes, yes.
or I just may make the size larger for you?
No, it's okay. It's visible.
Okay, so right now, as you see over here, the value is 0.07986 before the multiplication of -1. After the multiplication of -1, I got just minus before it.
Minus.
Yes, when I just subtract -1 from this value, and I got this function, and it is plotted over here. When in the graph, it is plotted over here. It is okay.
No, it's okay, sir. But can you open for the black diagram?
1 minute. Yes.
Black diagram, you are mentioned on the formula. It's a minus 0.8 is coming first, right? That's why I'm asking. It should be coming after the.
Your voice.
No,
Your voice is breaking.
in the black diagram, you are mentioned minus 0.8 coming first. Before that, the sign of 3x plus 0.1, correct? But it actually it's a minus 0.8 coming after the sign
Okay,
x.
okay, okay. You have the issue with this function over here.
Yes,
You just put this value. I just, for the sake of mathematics, I just put over here, because there is a confusion. If I just put 1 minute, I just put 1 minute. So sine of x, this function is multiplied by,
0.8.
yes, 0.8. Okay, now there is any issue, and right
No,
now
sir.
over here there is a bracket also. This one, because I multiply it with 0.8 minus 0.8, and over here also there are brackets. Right now it is okay.
Yeah, okay.
Okay, so this is the way how to create different mathematical. It is the basic mathematical function. You can create any function with this. Okay, so I just also share you the solar panel equations with you. 1 minute. Because in the case of solar panel, when you just go with the solar cell, there are some mathematical equations. I just show you different mathematical equation, how I just create the panel inside the LabVIEW. So over here I have different equations related to my paper. 1 minute, I just show you also the different equations. You can create using MATLAB also, you can create using LabVIEW also. It is up to you, because at the end there are mathematical equation. I just show you 1 minute. I am just downloading a mathematical paper over here. Like, this is the basic model of solar cell, mathematical model, and in this we just use different equations, like over here IPH, photovoltaic current, and the equation in this case ISC is variable, Ki is variable, T is variable. Using these equations, different equations, I just create solar panel model. Over here these are my, and I note is my output current. As you see in this model, I just create output current, IPH, IRS, ISH, different equations are there, and over here I got the my final VI. As you see over here, there are different variables like temperature, radiation, Ki, different variables that are available in the equation, and I just create different sub VIs like for shunt current, photovoltaic current, reverse current, and using this I create this final VI, and using these equations I just create a LabVIEW model for the solar cell. And I just, you just put your variable value, like if you want to go for 250-watt panel, you just put the parameter according to that. If you want to just create a solar panel for 50-watt, you just put the values related to that, and the values I just got from the mathematical modeling, or and it is available on the solar panel also in the data sheet. As you see over here, these are the different values, like what is the maximum power point, different mathematical values of these variable that I just go with in my case. Okay, so you create any mathematical model of, if you have any data, if you have available with any data sheet, you just create model of that function in your system also. So next function is my timed loop structure. So I just close all the VIs once. So over here I have a timed loop structure. Basically, if you want to go with different frequencies in the K structure, you have timed structure. Okay, this one, and this is my timed loop. Inside this loop, whatever is available, it works according to the given frequency. Like as I already created, I just create a new one so that you are aware with that. Control T. First, you just go to the time structure. Over here, select time loop. In this time loop, there are different functions. You just click on this function. As you see over here, you just select the source frequency. Right now in this case, I don't have any hardware that have 1 megahertz clock. Right now in my case, only 1 kilohertz frequency is there. Okay, so it is default case when you don't have any hardware with you. So right now 1 kilohertz clock is selected. You just select the period priority. In this case I just use this one. When I just make another copy of this, and in that case the frequency is same, but the period I just change. Let's check. I just change the period. Over here I just change it to 2000 milliseconds, and over here I just create a control indicator to check the loop time. If you want to just iterate in a single VI with different time periods, you just go with this timed loop structure. When I hit on run button, you just check. I'm just make it continuous run. You just check, because the period is different. Over here the period is 1000 and over here period is 2000. According to that, the both are working on different time scales, okay, in a single VI. And if you want to just let's want to stop it at different values, like I have a example of process industry. Let's I want to just build 10 Coca-Cola bottles for 1 liter and 5 small Coca-Cola bottles in that case, okay, 1 liter and half liter. So how to just create? So first I just over here add shift registers. Shift registers are also available in this case. So I just make it default, let's say integer type, and over here I just want to stop these values at some particular value. So 1 minute. Over here I just add on 1 after every iteration. So when 0 is there, 0 iteration is there, 0 plus 1 it give me 1, and in the next iteration 1 is there, 1 plus 1 it will give me 2, okay, like this. And over here I just use a comparison. When this value it is equal to 6, it will automatically stop my time loop. That is my time loop in this case with 1000 milliseconds. But in this case, when I just hit on continuous run button, let's check what happened. It will stop at 5, first loop, but the second one is right now continuing. There is no stopping condition on it. It goes to infinite value. But if you want to just stop it also, again just change conditions for it also. I just connect it to 0. You can use individual value also. Right now I am just using the same value. So over here I just again iterate it, create constant for it, and the value is 1. And in this case, when the value, because I want to stop this loop also, when this value, let's say it is equal to 10, it all will automatically stop it. So when I continuously run, you just make a while loop also over it. So in that case, you just need not to go with continuous running. So first one goes to 5 and second one when it is 9.
6 sound changing.
Okay. So again it is starting from 0. So this is how you can iterate with different values. You just go with time loop. This is the example. There are so many values inside it also. You can explore one by one. Right now 1 megahertz clock is not available. If you have with any device that is having 1 megahertz clock, you just select 1 megahertz clock also in that case. Right now in my case it is not available. It is 1 kilohertz clock. For that purpose you just need another hardware. For the default 1 kilohertz clock is there. In your system also 1 kilohertz clock is there. Okay. So this is the case of timed loop. You just add from frames also to it, like the case in the case of case structure. As you see over here, there are different frames. Right now this is my first frame, this is my second frame. These are also working according to your conditions, the which condition you just put inside it. These work according to that. So this is the case of timed loop structure. You just create any examples using this. I also give you the some practical problem related to that. You just create that one. So next function is my waveform function. How to build a waveform? Like I want to just start my waveform from point 10, and the period of change or the difference between first point and second point is, let's say, 1 or 2. You just how to change this. So in that case, I just first delete this one. So you just go with the cluster. Over here, this is a bundle. You can use bundle or bundle by name. If you want to just check the initial structure of a graph, you just drag, select the graph and put Control H. As you see over here, this is the structure. As you see, this is the symbol related to build function, cluster, bundle cluster. X naught is my initial point, delta X is my change, 1 point to second point, the change between 2 points, and Y is my input array. Okay, so for this case, I just create this waveform. I just go with the for loop. The case of for loop is just to create different values. So over here, I just create a control how many values I just required in my waveform graph. It is selected from here. Let's say it is 50. In this, I just use a random number. I just multiply this random number with my iteration, and these all the values just collected over this edge, all the values stored over this value. And now I just go to the bundle function. I just go with a numeric constant initially. Let's say I just make it control also, change to control. I want to just change all the values. So right now this is my initial point. I just put in. Over here I just again copy this. This is my change. This is my change, delta X. I just increase it, and over here I just got the point values, different point values. So this is my waveform graph. I just connect this to the waveform graph. So when I just hit on run button, right now difference between default is, let's say, 1, and over here initial point is 0. So let's check what is the error. The wire is not connected to anything. This one, control B. Right now broken arrow gone. When I hit on run button, as you see, from 0 to 50, I not 50 up to 49, I just got different values. Okay, 0 to 49. If you want to just move this value from here to over here, let's say I just put 10 over here. Now these value, the initial value goes to over here. It's 10. As you see, the scale is, and when you just want to just not want to auto update your system, in that case auto X scale, just remove it, put over here, let's say 100. Fix your horizontal graph, let's say it is 0 to 100. So as you see, when I just make it continuous run, as you see, in this case it is running very fast. I just put some delay inside it. In that case, you just need to use while loop when you just want to go with continuous case. So over here I just put while loop over here, create control, just run it. As you see, because random number creating different values, according to that my function is changing. And when you just increase this one, it is moving left to right. Okay, but over here these are my different points. Let's say I just put 2, as you see. It is scaling one point to another point. What is the difference? Right now, I just have only 50 points, but the difference between 2 points is 2. That's why it is gone from 0 to 100. When it is up to 3, it goes to 0 to 150. I just show you. Let's say I just put 500 over here, run it again. As you see, number of points are fixed, but the scaling is changed. Okay, so as you just put 4 over here, it goes to 200, 5 on a scale of 50. You just multiplying. Okay, so this is how you can change a VI, or how you can create your own graph using waveform graph. So in this case, we have different functions also. It is okay with you?
Yes, okay.
Okay. So next function is the updating process of my waveform graph or chart. Control T. Over here, I just create a graph, not graph, chart. I just put a mathematical function inside it. Let's say sine function. And over here, this is my waveform chart. And in the case of chart, there are 3 different options to update it. Create control. One time delay is also there, otherwise it goes very fast. So as you see, right now sine wave is created using waveform chart with the help of loop. But over here, in the case of chart, we have chart history length. It is default 1024. It is up to you how many values you want to store. Right now, it is creating the values is related to this iteration. Okay, so right now, as you create indicator over here also, you can also check how many values are generated by this function, and it also store the values. Like when I just stop it, it is started from 144. When again I hit on run button, it is not starting from the initial point. In this case, it is the default property of this waveform chart. Okay, so when you want to change, 1 minute,